All right, so in this problem, we're given a function, and the function describes the number of banks in a given, well, as a function of the time since 1900. So I'm trying to find a I'm going to minimize this for a second. Okay, so number of banks in the country is given by this function here. It's defined as a piecewise function. Now, how piecewise functions work is you consider the x value, the input that you're working with, and if it is less than 90 in this case, we use the top rule. Right? And if it is 90 or larger, we use the bottom rule. Piecewise functions always have two or more rules, and the rule you use is determined by a specified interval on the x-axis. So the other thing to consider here is make sure you're using the right variable. And x is not defined as the year. X is the number of years after 1990. So when we go ahead and do like 1970, we're really talking an x value of 70. In 1990, we're talking an x value of 90. And then in 2010, it's 110 years later, right? If you start in 1990. So we would have to use the correct values of x here. Oops, I meant to be an eraser. So you can do this by hand, just be careful. Now I'm going to show you a quick shortcut because, this is a calculator driven class. We can do this in the calculator. Again, if you do it just by hand, or even if you want to let the calculator help you, you don't use this trick. Make sure, again, you're plugging these into the right spot. 70 is going into the top rule. 90 is going into the bottom rule. That's 90 or larger. And then, of course, 110 is going to the bottom rule. But you can actually enter piecewise function into the calculator. Let me make it a little bigger. And the calculator can assist you with a majority of this problem. So I'm going to start by in y equals. We're going to need to actually close off each rule in parentheses. I'm going to type the 84.7 in. 84.7. We started off with a parenthesis, right? Plus 365. Close parentheses, and then you want another parenthesis. And here we're going to specify x. So we choose the x variable, which I just realized I'm missing an x here. I'm going to go back. Insert an x. There we go. Okay. So, we have another set of parentheses here, and we're specifying x. And here we need to pull up one of those inequality statements, which is under the test, which is a blue button right tied to the math button. So you would hit second math to pull up the test menu, and we want to choose the less than, which is the fifth option. And then, of course, type in 90. Then you want to close off that set of parentheses. Now we're going to put a plus sign in, and we're going to type the next rule in parentheses. So in parentheses, we're going to type in negative 376.5x plus the 48689. Close those parentheses, and then open up a new set of parentheses, again, x. And then to get the greater than or equal to, again, we're going to click second math. And we want the fourth option in this case, greater than or equal to, and then you type in the 90. And then you can close the parentheses. So once that's in there, right, and assuming that your table set, like I was mentioning earlier, second window, you want your independent variable set to ask. From here, you can just go right to the table, and you can type in whatever values you want. Right now, remember, we wanted 70 for x equals 70 for 1970. In 1990, we wanted x equals 90. And in 2010, we wanted x to be 110. Okay. So those are the three corresponding values for part A of this question. 18,294, 14,804, and then 7,274. So these, of course, were all of the various numbers of banks in the years that they asked about. Okay, now as far as the graph is concerned, it is multiple choice, like really graphing is in this class for them. I mean, it's almost exclusively going to be either multiple choice, or in some places you have to use some graphing tools in MATLAB+. So in this case, one thing you can do is you can try to visualize and pick some numbers out. There's a lot of different approaches you could really take. You could simply plug in 90 into the top rule, right, to see where its open circle is, to see if it lies above or below the blue. But if you use the trick I was showing you in this video, where you have the function plugged in the way I did, then you should just be able to go to the graph. And you can't see anything. Why not? Well, it's because we want our windows to be set appropriately. The parameters of the viewing window here. So we're going to use the exact same ones that they have. If you go to Window, and the graphs, as far as what we get to choose from, the smallest y value shown is 0. We go from 0 on, or we'll start with the x's since that's what's listed in the calculator first. Smallest x value is 70. So we want to set as our x min 70. X max. Well, the largest x max, or the maximum x value that's shown, is 120. Then we go down to the y min. Well, the smallest y is a 0. And on the y-axis, the largest value is 25,000. Don't worry about changing the scale. That'll just change. You, in theory, could find that, but that's not important. It's not going to help us really as far as pick out the graph. So if you just go ahead and graph, doing it this way, will give you a very good indicator of what the graph should what the graph should look like. Now, of course, it's not these two. Right? So the only other options are these two. And now the calculator won't show you the open circle, so you've got to make a decision here. Well, if you go back and look, the rule defined to the left of x equals 90, which is where the graph is splitting up, so to the left of this line here, so this rule, that's where x equals 90 is not included, right? It's just less than, not or equal to. So this is the one that needs the open circle, not this one. So it turns out that the correct answer should be A. Okay, hopefully that helps. Let me know if you have any more questions. Take care. Bye.